Hello, everyone. In this lesson, we're going to talk about how to reduce complex fractions. So please get your paper pencil with me and do it along with me. Okay, I prepared 3 examples. And the first one is a fraction form, but they're fractions in fractions. So here's the new denominator and here's the numerator. To reduce this fraction, first of all, we need to identify the common denominator. The common denominator, we have 1 fraction, 2 fraction, and 2 other terms, which you can think of their denominators of 1. So the common denominator is really 3 times x. So what we do is that we're going to multiply 1. And the 1 is chosen as 3x over 3x. Okay. Once we have chosen 3x, and we're going to multiply the 3x with x. 1 over x, and we multiply 3x. And we're going to multiply the 3x to the denominator. Okay, so that's the process. So by doing so, so let's reduce it. Wait, let's reduce it. So 1 over x times 3x, we get 3. And 1/3 times 3x, we get x. That's how we got rid of the fractions in the numerator. So we have one numerator, another one denominator. And next, we're going to reduce it if possible. Knowing that 3 minus x, okay, is negative of x minus 3. Okay, the latter, you can verify, right? You can verify this is true. So the next step is that we're going to replace the numerator by its equal. Okay, so numerator 3 minus x will be replaced by negative of x minus 3 in parentheses. So that way you can see x minus 3 and x minus 3 will be reduced. So we will end up with, we have a -1 in the top and 3x in the bottom. So, and by this time, the complex fraction has been reduced. And let's look at the second example. In the second example, we will do the same thing. Oh, by the way, when you express your work, okay, you can express them vertically like that. And, that's usually preferred by a lot of professors. Either vertically or horizontally, okay? And in the second one, I'm going to do it vertically. All right, 200%. Okay, so we're going to do the same thing. Common denominator. So what is the common denominator? Obviously, in this case, the common denominator is x squared multiply x plus h squared. I think we prefer it larger. Okay, so numerator is the same as the denominator. So we multiply by 1, and this 1 is constructed as such, which is the common denominator divided by the same common denominator, which is 1. Anything times 1 stay the same. So we validated the equal sign, equals 2. Okay, this step can be done. You can do it, in the following way. Okay, so the numerator on the top, so we're going to take the whole thing here, multiply that, and multiply that, the denominator, of course, also multiply the same factor. So that's really what's going on. And you can, then you reduce it, x plus h squared, take away that x plus h squared. So the whole thing now is just x squared minus, and 1 over x squared multiply x squared, that's equal to 1. So we got this form, right? And next, we want to reduce it further if possible. Okay, there are multiple ways to reduce it. And what I like to do is that I'm going to keep the denominator. On the numerator, okay, I'm going to use, you can do the FOIL, okay, you can do the FOIL. I'm going to do this. I'm going to apply conjugate a squared minus b squared. And that is equal to a plus b times a minus b. And in our situation, a is x, b is x plus h, right? So we apply this formula to x and x plus h, which is b. And as a result, right, a is x, b is x plus h, b is x plus h. So we got that. So then this result will be placed on the top. And of course, we can reduce it. Wait, a is x, sorry, a is x, a is x here, right? So a is x, you can see. You don't have to show this part of the work. And I show it just for you. Okay, I just show it for you. And you don't have to show it. You don't have to show it. Now you look at, if you reduce this, and you will find this is a 2x plus h. And this latter one is going to be negative h. Right? So you can just show this step, maybe. You can go straight to the second, third. Okay? And now we can see there's some common factors here, which is h, right? H and h will be reduced. So this will be -1. So -1 times the whole of it, and the negative sign can be placed in the front. And we can remove this parentheses here. And that is done. That is done. So this is the second example of a simplifying complex fractions. The third example, and this notation doesn't seem like a complex fraction, but it is indeed, okay? Because we understand in power notation, right? B raised to the power of -1 equals to 1 over B. 1 over B. Okay, so what we have here, we have indeed 3 plus h to the power -1, and this is really 3 plus h under 1. And 3 to the power -1 is 1/3. So this way you can see it's a complex fraction. And we can remove this parentheses, of course. And then from here, we're going to reduce it as a complex fraction, We're going to find out the common denominator, and the common denominator here is 3 times 3 plus h divided by 3 times 3 plus h. And then we take the numerator, right? You can combine these terms, these steps. You can multiply multiply, and this denominator is multiplied with the denominator, right? Multiplication of fractions. So multiplication. Simplify at the same time. So 3 plus h, take away the 3 plus h here. So this is going to be 3. And 1/3 times 3, that's going to be 1. And you can write 3h here, right? And next, so it doesn't have to show so many steps, okay? So over here now is 3 minus 3 minus h. So on the top is minus h. And next step, h and h reduced, we're going to get a simplified form. The top is -1. The bottom is 3 times 3 plus h. Finished. So that's the 3 examples of reducing complex fractions. Thank you for watching.